Okay, this is a quick demonstration of gimbal lock. In the 1970s, these were actual platforms that were in ships and aircraft. And this is what the platform looked like. It had accelerometers on top of it, and it had stabilization gyros, which kept the platform level. And notice that it was pointing north, east, and down. So this was a Ned frame that we've talked about in class. Now these torquing motors right here, these torquing motors kept the inner platform level with respect to the tangent plane of the Earth and pointing north as the aircraft flew around. So that's how the basic system worked. And you could use the angle between these gimbals. If you looked at these gimbals here, you see here's a gimbal here, and here's a gimbal here. And then the angle between these gimbal structures gave you the Euler angles. You would just measure the angle between the gimbals. For example, if this was the vertical gimbal, and then you raised theta. If theta increased, then the angle between these two gimbals here, this angle would be a measure of theta. And that's how the system was operated. Now you can see that if theta became 90 degrees, these two gimbals would align with the blue marker that I've got shown. Those two gimbals would align, and this pivot would align. They would be aligned. They would be lined up, and then your net system would just look like this with the vertical torquing motor, and then your theta would be 90 degrees. Your platform would still remain northeast and down in the center. It would still remain northeast and down. But if it received any yawing at all, if it yawed at all, then the platform would be physically disrupted. So any yaw would physically move the platform from its net setting, and you would have to restabilize your system. And so that's why it is called a gimbal lock. The gimbals actually locked when theta was 90 degrees, and you would have to land and start over again. You could add a fourth gimbal, so you could actually put a fourth gimbal around the system and eliminate gimbal lock, but you still would, of course, have psi heading and phi roll angle undefined at theta equal 90 degrees. But that's where the name comes from. That's how it's stuck. Now it's all done, it's all done numerically, and instead of having gimbal lock, a physical locking of the system, what we have is today's system. We have a divide by zero, which is just as catastrophic. As a gimbal lock system. You'd have to restart your system. That's what gimbal lock is physically and numerically.